Assalamu alaikum wa rahmatullah. Alhamdulillah, we're about to begin. I'll just wait a couple of minutes. Hopefully, inshallah. Let's check also whether it's coming up on my Facebook. Okay, we got a couple of people. That's good. For a moment there, I thought I was going to be on my own. Yeah. Alhamdulillah. So today we're going to talk about, just after a couple of minutes anyway, inshallah, we're going to have a quick discussion about the question that was sent to me. So, if some of you listened to a previous Facebook Live that I did, which was on the fallacy of composition, we went through some questions that was originally sent to me. We thought we'd have a discussion first on Facebook, and then on the basis of that discussion on Facebook, we then had a Facebook Live where we sort of went through maybe some of the points in a little bit more detail. So I thought, inshallah, alhamdulillah, there was some, benefit in that perhaps I'll do it again. And obviously you guys have an opportunity to raise your own questions, your own comments, any criticisms, any points that you would answer as well, or any questions specific to what we're going to discuss today, which is this question. Now, I've tried my best to try and get good lighting, so that's why I'm slightly in a different position than last time. So hopefully you can hear me, you can see me, can everybody hear me, see me? Assalams, Ammar, Shafiq, you can hear me? Inshallah. Nobody's responding yet. Maybe they're still waiting for us to get really going. But yeah, so this week, inshallah, or this time, we're going to talk about the issue of the energy, whether it can be created or destroyed. Oh, Ilyas has said he can hear me. That's good. Alhamdulillah. Salams to you, Ilyas. Hope you're doing well. Abdul Jabbar as well. Alhamdulillah. So anyway, so I thought we'd inshallah just maybe look at this particular question. Perhaps maybe inshallah, like I said, I might turn these into maybe more focused type videos. I know one of the brothers was telling me to make sure that I try and do videos for these as opposed to just simply Facebook Live. So maybe smaller bite-sized type pieces. But I thought inshallah it'd be good just to have a discussion, and this is I like that anyway. So we have a quick discussion about this question. So what was the question? So we've got 10 people. We'll start now, inshallah. So what was the question? The question that was sent to me was this: people say energy cannot be created or destroyed, and this is proof for the eternality of the universe. How can we prove the dependency, i.e., that the universe itself is created? So this brother's asked this question, and he effectively follows through the first law of thermodynamics. First law of thermodynamics is what? Energy cannot be created or destroyed, but transforms or conserves or transforms from one form to another. This is the first law of thermodynamics. We all learn this in school. This is not something unusual, and we accept this generally as our observation of the universe. That energy, we can't create it, nor can we destroy it. It just transforms from one form to another. And I'll put the famous equation up there, which is E equals mc squared. I'm sure we all know the equation, which is energy times mass times the speed of light squared. Hopefully, inshallah, maybe somebody can maybe tell me what the speed of light is. I don't know if people out there know that. But anyway, that's the equation in which we take energy, or we can take mass or matter energy, how they're interchangeable to a certain extent, and therefore, you can take mass and you can turn mass into energy, and the amount of energy that's going to be released. Mustafa Said has said, that isn't a reasonable argument from atheists. This is a fallacy. If the universe was eternal, we would have run out of usable energy. Ooh. So alhamdulillah, brother is preempting some of the points, inshallah, which is a good point. So anyway, so how are we going to answer this question? Firstly, I think it's important to note that when we look at these questions about proof of the existence of Allah subhanahu wa ta'ala and some of the arguments that the atheists themselves they present, or these various arguments that exist out there, some of my points that I mentioned might be technical. Some of them, might use certain, big languages or points that might be relatively, may seem that you have to really wrestle with these arguments, but really these are basic points, these are basic arguments, and sometimes the technicality comes in only simply in order to explain and in order to try to refute some of the arguments that are being used against belief in Allah subhanahu wa ta'ala, belief in the Creator. And so we should be very careful that not to dwell upon the complexities too much, because sometimes the complexities sometimes can muddy away the water. One thing in my experience is that when it comes to the issue of debating and discussing with atheists, that debating and discussing with them doesn't necessarily increase your iman in Allah subhanahu wa ta'ala. Now, it might seem strange for me to say that, but what I'm saying is that sometimes to build your belief in Allah subhanahu wa ta'ala, obviously you build upon a rational framework, but getting into excessive debates and excessive argumentations doesn't necessarily build or accelerate or increase that love for Allah subhanahu wa ta'ala. So these things, these types of videos here are for a specific purpose. These are specific questions that are being asked in order to try to muddy the waters, so that we sometimes don't appreciate the intellectual foundations that we're upon, and then suddenly maybe potentially some people may be thrown into doubt regards to this. So this is what we're going to. We're going to go into some of these points. So in terms of this, brother John Fontaine, brother, maybe we could use some of that energy to get a better camera angle. I will try to get a better camera angle, but the camera angle also is inshallah focusing on this. SubhanAllah, I've just been at Maplan, I've been to Curry's, I've been to Carphone Warehouse looking for mics, looking for cameras and all sorts, so I couldn't find anything really, so I've had to use the iPad again. So inshallah maybe I'll have a look on Amazon, but I think that takes a few days to get. So anyway, let's take this look at this particular question. So this question is focusing upon first law of thermodynamics, so first law of thermodynamics, as we know, energy cannot be created or destroyed, but transforms from one form to another. So, okay, there's a number of ways to answer this question. It's not really a long discussion, hopefully not anyway. First way that we can look at this discussion is firstly understand what do we mean, particularly in science, regards to what a law is, Because sometimes when we think of laws, we think of something which is irrefutable, immutable, something that cannot change, something is definitive, definite, it is necessarily logical that this law will always exist. So this is sometimes what we understand. And so when we start talking about the potential of creating and destroying energy, we think that's impossible because it contradicts the law. It contradicts the first law of thermodynamics. Now, we need to understand that when we talk about laws within the scientific, terminology, we're not talking about things which are necessarily, necessarily logical or absolute or definitive. What we're talking about when we talk about laws is we're talking about those things which have so many numerous observations that those observations, they consistently reinforce a particular theory, a particular understanding. And that theory and that understanding is what we then term a law. So for example, we've had so many observations of energy and how it transforms from one form to another, how we cannot create energy, how energy never gets destroyed, but rather becomes something else. So for example, maybe, a light, the light, when you switch it off, the light's no longer, it's not like the energy's disappeared, but rather the energy is now stored within the electricity or the heat that's been dispersed from the light. So energy So these observations, they reinforce a fundamental concept. And these fundamental concepts or fundamental theories are what we then term as laws. So laws of thermodynamics or laws of science. So that's first thing is that when we talk about laws within science, they're not definite, they're not irrefutable. Yeah, they're not, there's no idea that there's an impossibility of something being the opposite. It's not like that when it comes to laws. Why do I say that again? Because, as I said, it's based upon observation, and the observation comes to certain conclusions. And if you remember our previous video, Facebook Live video that we did, we talked about how when you look at observations based upon, when you come to conclusions based upon limited set of observations, then what you have is you have an inductive process of reasoning, yeah? Induction. And as we gave in the famous example last time we did this video, we gave the examples of swans, black swans. So if a person, he looks at one swan and he sees it's white, and he looks at second swan, he sees it's white, third, fourth, fifth, sixth, all the swans that he sees are all white, then he might come to a conclusion that all swans, yeah, are white. Yeah? Are white. Yeah? So he might come to that conclusion. But that's because his conclusion is only built upon his limited sensation. Yeah? And therefore he's induced. Yeah? Induction. Deduction works in the opposite way. Deduction is where you have a general statement and then you come to a particular conclusion. Induction comes where you've got particular statements or particular premises, and then you come to an overall general statement or overall conclusion. Yeah, exactly as Mustafa said, from particular to general. Exactly, that's the point. So when we look at laws within science, all laws within science as itself is simply an induction. It's an induced process. So it's not logically necessary for energy not to be created, nor is it logically impossible for energy not to be destroyed. It's just what we've currently observed within the universe. Yeah. So that's important to understand in terms of the first law of thermodynamics, that laws as themselves are not irrefutable, immutable. They can be changed, they can be differed over, they can potentially have an observation where we do in the future observe energy being created or energy being destroyed. So that's the first thing. Second thing is this, is that because it's induced, because we understand that energy itself, and this equation here, E equals mc squared, yeah, energy times mass times the speed of light squared. I think somebody gave the answer there, which is 300,000 kilometers per second is the speed of light squared. So when we look at the issue of this equation, when we look at in terms of how energy operates, it doesn't operate in a non-definable fashion. It operates according to rules, it operates according to principles, laws, systems itself. So energy doesn't obviously define its own laws, doesn't define how it operates. You know how, for example, when you switch on a light bulb, you'll get light and also heat coming from it. It's not energy that's deciding what it's going to produce when you switch on the light. It's the systems that are imposed upon the light bulb, the electricity, the filament, etc. that causes, that we know will therefore create the circumstances for which light, which is one form of energy, will be produced from that. Yeah, I was going to say could be created, but obviously it's not created. It's produced. It's transformed from electrical energy to another type of electrical chemical energy, which is light, or what we observe as light. So why do I say this? Why do I say that it is imposed upon it? Because again, if you remember last time, those of you who were here last time, they will understand that when you induce something, you also, and when you've got something which is and it has laws imposed upon it, then we understand that it is dependent. Yeah. So energy is dependent, yeah, meaning that it doesn't just exist, but rather exists according to certain attributes, certain equations, certain systems. Does that make sense? Hopefully that makes sense. inshallah, that energy is dependent upon, there's some sort of regulation for energy. Yeah? And that regulation for energy, how we came to certain laws of thermodynamics, yeah, how we understand energy operates and works within a closed or open system. All of these things are things that allow us to understand that energy does not exist independently, but rather exists because it's built upon some sort of dependency, yeah? Some sort of thing that's imposed upon it. And that's why we say it's dependent contingently. Yeah? So if you remember, I almost wrote on the wall then, I would have got into trouble with my wife. But contingently, if you remember last time we talked about contingent and we talked about necessary. Yeah. Now we gave the example of contingent and necessary, and we explained the two. And we explained why it's important to understand the two. Yeah. And we gave the example and we talked about a triangle. If everybody's probably remembering this now, that so somebody's asked a question. Contingent is within the creation, right? Yes, contingent is within the creation. So really, just to very quickly explain this point. Yeah. So when we talk about contingent, we're talking about something which is dependent upon something, but not in a necessary way. Yeah, so it's dependent, but not in a necessary way. So if I turn around and I say triangle, yeah, if you can sort of see it a little bit, so you can see the triangle there. You can say a triangle is what? It's got three sides. By necessity, it has to have three sides. Yeah, so by necessity, it has to have three sides. But it doesn't have to, by necessity, be black. Yeah, if I had a red color pen or a blue color pen or any other color pen, I could draw it into a different color. Yeah, I could draw a red triangle. Yeah, now the red and the black and the blue are contingent. Yeah, so they're not necessary to the component of the triangle. Yeah, as we mentioned last time. So therefore, we understand that for it to be black, something must have determined it to be black. Yeah, light spots on the triangle. Yeah, I know. I'm trying to. I've got a lamp which upside down slightly, pointing towards me, trying to get enough light as possible. But yeah, so I'll do it here. So triangle, yeah. So we got the triangle. So it could be any color. So the fact that it's black as opposed to blue means somebody has determined it to be black as opposed to blue. Yeah. So let me give you another quick example, analogy of this point. You know, if I had wood, yeah, or if I had a wooden table, then for it to exist, you need to obviously have wood, yeah. Now, for that wood, if you've got a wooden table, you need to have wood. If I have wood, it does not necessarily mean I have a wooden table, because the wood could be a tree, it could be a table, it could be a cup, it could be any other form. So you recognize now that because it's a wooden table, it's what they term material cause. What it's made of is wood, that's necessary for its existence, but also something else is necessary for its existence, is that there must be something other than wood that caused it to be a table. I fashioned the table. Why do I mention all these points? Because it comes back to this point about E equals mc squared. It comes back to the first law of thermodynamics, which is that if energy is not itself necessarily creating its laws, its systems, its dependency, then something else is imposing the relationship between matter and energy. These are not necessary relationships. Yeah, they are things that we just observe within the universe. And not only do we just observe them within the universe, but in fact, they adhere to this pattern to the point that we can call it a law within science. Meaning that there's a consistent pattern of behavior that we observe within energy, which itself and the universe did not determine, so therefore it must be determined by something else. It's dependent upon something for it to adhere to these laws. Who is it dependent upon? It's outside of the universe, and obviously this is what we believe as Allah subhanahu wa ta'ala. Now I forgot to get some tissue, so I'm going to have to try and rub this points out, yeah, with a piece of paper, which is not really working very well, but don't worry. And I'll try not to write on the walls as well. Don't want to get into trouble. So anyway, so really not done very well, but don't worry. So we got the first point, which is this. So how do we know that energy cannot be created or destroyed? How can we say that's not eternal? First point is this, is because energy, is contingent. Yeah? Behaves in a particular pattern that itself did not determine, and therefore it was determined for it. Like, for example, a wooden table. Just because it's made out of, you've got wood does not mean you have a table. You need to have something other than the table, other than wood, in order for you to produce the wood into a table, because it can have multiple possibilities. So energy could have multiple possibilities in terms of its behavior, but the fact that it has this possibility as opposed to any other possibility indicates that therefore it's contingent, and this pattern is consistent. So somebody is imposing the pattern, imposing the relationship upon energy itself. So we understand therefore it's dependent, on that basis. So the second point, and I'll quickly run through this very quickly, inshallah, this point. So the second point is this, obviously, is that anything that exists within time, is going to have a beginning. This is a point which we can prove in a number of ways. First way is, how do we define time? Do we define time by the measurement of change or the measurement of the movement of objects? So measurement of change. Measure change. Try and do that to make sure it's clear. Or movement. So when we look at, and another way of also looking at it is measurement of events. Now those of us who've probably heard this point before will know where we're going with this, which is the fact that if anything exists within time, which means the number of events or the measurement of events, then the measurement of events or the number of events will either equal infinite or finite. And there's a number of ways of looking at this. First way is to say that events, number of events, well, event 1, event 2, event 3, for example, maybe event 1 you went onto your phone, or at event 2 you clicked on the Facebook app, event 3 you went and you saw this video and you clicked on it. These are events that take place. Now these events are discrete events, they're events that you can add up together. Now if the number of events are infinite, so if they're infinite, which means therefore time's infinite, which is another way that potentially people could say energy is infinite, then we would say that's impossible for a number of reasons. Because one, we would not get to this moment in time. So just imagine this. If I said to you that I'm going to give you this pen, after 5 minutes, when will you get it? After 5 minutes, isn't it? If I turn around and I say I'm going to give you this pen after 10 minutes, when are you going to get it? It's going to be after 10 minutes. If I said I'm going to give you, so each minute after 10 lots of minutes, you'll get this pen. If I turn around and I say you're going to get this pen after an infinite number of minutes, when will you get the pen? You can type in the comments if you want. You're not going to get the pen, are you? Obviously. Does that make sense? Hopefully that makes sense, inshallah. So therefore what we find is that the number of, so when we turn around and say time has to have a beginning, it means for us to get to this moment in time, so this moment in time we had to, click on the app, we had to open the phone or the computer, we had to maybe charge the phone, we needed to do something else, we need to do something else, we need to do something else, all of these things, we had to do. Now if those number of events go back forever, for infinite, we would not get to this moment in time, So we wouldn't get to this moment. If we've got an infinite number of events to get to this moment in time by which you're listening to me and watching the video, then we would not get to this moment in time. So therefore, we know that time has to have a beginning from that perspective. That's one way of looking at it. Second way of looking at there needs to be a beginning in time as well, is to say that if you've got a number of events, yeah, that's meant to be number of events equals infinite, which means that you have to have a sum of events, yeah, which are going to be finite events, yeah, discrete moments in time, can equal an infinite number of events. Those of you who have listened to this those of you who listened to this, the previous one before, will know, yeah, that it's impossible to have this. I'm trying, sorry, the light's getting in the way. So anyway, so they know that the sum of events cannot equal infinity because the sum of finite cannot be infinite. We know this, yeah? I should have really got a tissue before I came downstairs to do this, but anyway. So anyway, Mustafa said circular reasoning well explained. Okay, that's good, alhamdulillah. Right. So we said, why did we say sum of events equals finite? Yeah, the sum of limited equals finite, because we gave numerous examples of this last time, or we gave a couple of examples. We gave the example of the infinite number of marbles. If you've got an infinite pile of marbles and you cut them in half, then each half of infinity will have infinite number of marbles. If you cut them in quarters, you would have infinite number of marbles in each quarter. Yeah, so you can't have an infinite number of finite things because it's an absurdity. It's what we term a paradox. Yeah, so it's a paradox. Paradox means contradictory statement. It's a contradictory statement, like the liar's paradox. This statement is a lie. So you can't have that. So as a result, you can't have an infinite sum of finite things. Now, if brothers want me to explain that again, I'll explain it again, inshallah. But what this also proves, therefore, is that the number of events must be finite. Yeah, if the number of events must be finite, there must be a beginning event. If there's a beginning event and the universe and energy exists within that, then the universe and energy has a beginning. Yeah, so time has beginning. Therefore, that's another way of demonstrating that energy also must have a beginning. Now, the third way, and I'm going to quickly end on the third way, inshallah, because it's 20 minutes already, so I wanted to keep it as short as possible. Third way, and the brother's already mentioned this. Brother Mustafa is still watching, he's probably still here, yeah? Which is entropy, yeah? Now, what's entropy? Does everybody know what's entropy? Entropy is what? Yes, Akhi. Mustafa is saying yes, Akhi. Alhamdulillah. So what's entropy? Mustafa, you must know. Entropy is, what is entropy? Entropy is the measure of disorder, yeah? No, I haven't heard of, not anthropy, entropy, different thing. Yeah, entropy, yeah, that's right. So entropy is what? Entropy is actually the second law of thermodynamics, yeah? So when you say the first law of thermodynamics is what? Energy cannot be created or destroyed, but transforms from one form to another. Entropy is the fact that entropy is a part of the second law of thermodynamics, and entropy says that entropy always increases. Yeah, in a system, generally in an open system, it will always increase. Yeah, or in a closed system, they'll say it's either increases or stays the same. So they say entropy will always increase. Now, really quickly about entropy. This second law of thermodynamics was discovered during around about the Industrial Revolution with steam engines, and what they found was that it wasn't just sufficient to have energy to produce steam. Rather, what they needed was a differential energy. They needed a cold trap. They needed something which isn't hot and is hot, because then energy is able to be useful. It flows, yeah, from one form to another. Now, entropy, when it always increases, it means that the useful energy, basically what you need is a difference between one region which has energy and another region has less energy. In order to have that, you can have chemical reactions, you can have change, you can have events, you can have things happening. This is what entropy is all about. Yeah. So you need to have this ability to have one area, one region of low energy, one region of high energy, in order for you to have a chemical reaction take place. People who do physics, who do chemistry, they'll know this is not complicated. There's not like any complicated regards to that. So somebody's texting me something. All right, somebody's saying that I'm arguing a straw man. I'm going to read it out. Should I read it out? Shall I read it out? Don't you think that by not mentioning in a closed system, could you mean you're arguing against a straw man? I.e., when people use the first law of thermodynamics to say, how can energy have been created? The law isn't relevant to the creation of everything, just the creation within the existing universe. The brother's right, obviously. Jazakallah khair. I think he texted me this. I don't know if he wants to be mentioned publicly. But obviously, that's correct to a certain extent. What we're talking about is that within the universe, we're not necessarily talking about the energy being created, what we can sense or what we can perform within the universe. That's fine. However, when we talk about entropy, really quickly now, but just as a point, just on this issue, is that when some atheists, they turn around and they talking about energy cannot be created or destroyed, they talk as though it's an absolute, it's something which has to always occur, that it's therefore eternal, will always exist, it's a law, and that cannot be changed, it cannot be differed upon. So anyway, entropy, as this point. Jazakallah khair for keeping me anonymous. All right, it's a good job I did keep him anonymous then. So entropy. He's my mystery caller, as he called himself. So when we talk about entropy, and this is the third argument that we're talking about here now. So we're talking 3 arguments. The third argument about entropy is that entropy always increases. Yeah. And that means, in practical terms, you have a distribution of energy, and the distribution of energy becomes evenly distributed across the system. Yeah? Does that make sense? What did they discover in the Industrial Revolution with steam engines? You need to have differential amounts of energy in order for you to have chemical reactions or change to occur. As soon as the energy evens out, becomes homogeneous throughout the whole system, then the system will stop working. This is what they mean by entropy always increasing. This is what they mean by the second law of thermodynamics. Now, what does this mean? What is it in relation to first law of thermodynamics? It means this, is that if the universe has always existed forever, then entropy would have reached its maximum amount of state. It means it would have resulted in the universe being achieving the energy distribution of the universe being equally distributed across the universe. So we'd have reached that if the universe was eternal. So if the universe was eternal, if energy has always been there, then energy would have reached a state of complete, equal, even distribution of energy throughout the whole of the universe, and therefore you wouldn't have me speaking, you wouldn't have your iPad working, you wouldn't have your phone working, you wouldn't have lights working. Nothing would be working, and this is what they call the heat death of the universe. Yes, this is what they call the heat death of the universe. Yeah. Now, one argument against this, by the way, this is a bit more of a sciencey type argument. This heat death of the universe. Mustafa said that is exactly the point many philosophers also make. Alhamdulillah, that's good, man. So I'm not just talking on my own as well in regards to this. So heat death of the universe means, therefore, that nothing will occur. That means entropy has reached its maximal state. Maximal state. If time is eternal, and the universe is eternal, and energy is eternal, would have reached the maximum state by which nothing occurs. Because energy will be distributed evenly throughout the system. Some people say because the universe is expanding, that can counteract it. But even if the universe is expanding, what you'll find is that the total number of energy will just slowly cool the universe down, even if entropy will not reach its maximal state. So therefore, things still wouldn't work. So these are just 3 arguments, very briefly. Well, it wasn't that brief, but as brief as possible, inshallah, to explain Yani, why we can say energy is dependent. First argument that we mentioned is that laws within science are not considered absolute. They're not like logical, necessary laws. Yeah, these are induced observations, and potentially other observations can come along and change the paradigm. But because we've got so many observations, we don't disagree with it. We accept it, and it becomes what we term a paradigm by which we understand things. So the first point is this: is that laws are not any. When we talk about laws, don't get like thinking that physically it's impossible to create. Physically, for us, it's impossible to create. Physically, maybe within the confines within the universe, it's impossible to create. But we also know that energy itself exists because it's based upon laws that regulate it. It's contingent upon laws that regulate it. One contingency is this: E equals mc squared. Yeah, energy equals mass times speed of light squared. And because we've got this type of relationship, it's not any necessary for it to have that relationship. Could be other relationship, but because it's that relationship, then something's imposed upon it and set it as a pattern that we can see. As-Salam says, thank you, I will catch you later, inshallah. So for watching. So the second one is the first one is this point: energy is contingent and dependent. The second point is that time has a beginning, and we explained it in two ways. One, the sum of events, the number of events are finite, yeah, and therefore the number of events, if they were infinite, the sum has to be finite, because if there's an infinite number of events, that's logical absurdity, it's a paradox, it's a contradiction. You can't have an infinite amount of limited things. Marble example was a case in point. The second point, regards to which we mentioned as well, is that we wouldn't get to this moment in time if we had to wait for an infinite number of events to get to this moment. Yeah. Darba says salams, brother Sharif. Salams, sister Darba as well. So that's what we said in terms of beginning in time. There has to be a beginning within the universe, and therefore energy exists within the universe, so it has to have a beginning. And the third one we mentioned was the issue of entropy. Entropy is a measure of disorder, or the even distribution of energy throughout the system. If we had maximum amount of entropy, which is the second law of thermodynamics, by the way, then we would have reached the heat death of the universe, which means nothing would work. Therefore, you have to have a beginning in the universe and a beginning to the law of entropy, which is the second law of thermodynamics, which means a beginning to the first law of thermodynamics, and therefore a beginning to energy, which again is a dependency. If there's any quick questions or points that brothers want to or sisters want to raise, then please feel free in raising them now, inshallah, and I will see if I can try and answer them, inshallah. I think there was a large comment that I saw. Right, Uthman, he said, I know this is a bit off topic. Does that mean that there had to be a finite creation of Allah before the universe? Otherwise, we wouldn't reach this point in time. Would that mean that Allah subhanahu wa ta'ala was not creating or acting for an infinite duration before the first creation? Do we say that Allah subhanahu wa ta'ala could not have created or done an infinite sequence? I think infinite sequence of events. I clicked on his name and it says block Osman Ali Haybi. I'm not going to block him. It's a really good question, actually. When we look at this question, which I think sort of understands that, okay, if there's a beginning in time, then does that mean that Allah subhanahu wa ta'ala is outside of time, and therefore, when we talk about Allah subhanahu wa ta'ala creating before the universe exists, that means that Allah subhanahu wa ta'ala was before, quote unquote, in time? And if that's the case, then how can we say before? Because Allah subhanahu wa ta'ala, that we just said that time had to have a beginning, so how can you have a before time? Yeah, does that make sense? And some people say, well, how can you say that you can have north of North Pole? Yeah, you can't have north of North Pole, can you? Yeah, so they say, well, how can you have before any time exists, any concept of the before exists? It's a little bit complicated, but there's lots of different arguments or points to mention in regards to this. The first point is this, is that when we talk about time, when we define time, in our particular definition that we've given here, is the measurement of change, yeah? Or the measurement of movement of objects. Now when we talk about measurement of change, we're talking about limited things. So we understand time exists because of the change of limited things from one form to another, yeah? That's how we know that time exists. One is limited, another, the hands around the clock ticks, it moves, isn't it? So these are events, these are limited things creating change, isn't it? So when we talk about before time, we're actually talking about before limited things, yeah, before objects move. So in this context, we're talking about what they term in philosophy an ontological before, yeah, something which is like when we say Allah subhanahu wa ta'ala is beyond the universe. Now, time and space, the three-dimensional space exists within the universe, but when we talk about beyond, we're not talking about space outside of space, we're just talking about in the context of outside the scope of our creation. So similarly, when we talk about before time, we're talking about outside the scope of creation of time, the aspect of time, and we understand that time is so I'm just reading comment. So we're talking about before time, we're talking about before limited things. Yeah, before limited things. So there's nothing wrong with saying that. I don't think there's any other questions. I'll try to be as concise. I'm not very good at that, inshallah, but I'll try my best to be more concise in future if I take this. Just really quickly, there's a question that was posed to me a few weeks ago now. So I'm just going to read this question out, and maybe brothers. Somebody said, didn't we create time? Well, unless you have a relational or idealistic view of time, maybe that's some way of looking at it. Some brother, anyway, he's asked this question. I'm not going to answer the question now, but I'm going to answer the question maybe in a future time. It says, Assalamu alaikum wa alaikum salam. How are you? Alhamdulillah. Well, I have a question for you regarding the inimitability of the Quran. How do I know that nobody have made something like the Quran, despite the many attempts in history, like the names in this link, Ibn al-Muqafa, Bashir ibn Burd, Abul Atiyah, Al-Mari, etc. And then he's given a link to Wikipedia article on the Ijaz al-Quran. So the question is, how do we know that the Quran has not been matched today? Yeah, when there are claims that some people have attempted it in history. We'll leave that. I might put that up on my Facebook post and get brothers to answer that particular question. And maybe later on, inshallah, I might do a Facebook Live. Jazakallah khair. Hopefully, inshallah, that's been useful today, this quick session. If not, I'm just going to stop doing these. Okay. Assalamu alaikum wa rahmatullah.